The other thing that we need to do to begin this problem, again, we're going to do one slight thing before the problem begins and then one slight difference or change after it. The change before, and I'll just call it step 0, and that is in division is equivalent to what mathematical operation? Multiplying by the reciprocal. So all we need to do to begin this problem and turn it into what we've already done is invert and multiply. Okay, so all we need to do when we work to solve this, we can combine these two steps in the same step if we want to. It makes it easy. When we rewrite our original fraction here, x cubed is a monomial factor, so it stays. There's nothing to remove. X minus 2 is a first degree binomial factor, so there's no common factors. That's all you can do. Then we're going to invert and multiply. So we turn this into a multiplication. This 2x squared gets moved to the denominator. And then the original denominator, 2 minus x, is going to get moved up. But again, I can combine these in the same step. When I factor completely, remember, I do want you to rewrite your factors so that the variables come first. And anything that has a negative leading coefficient gets factored out. So the 2 minus x, we're going to factor out a negative. The 2 becomes a minus 2, and that number gets written second. And then negative x becomes a positive x and gets written first. So this would be my first step. I inverted and multiplied. At the same time, I factored and rewrote the expressions in their factored form. What that allows me to do then next is to cancel common factors. So as I work across, this x squared cancels with 2 of these, leaving 1. The x minus 2's cancel. And across the top, I have a negative x. Across the bottom, I have a 2. So I get my simplified form. And then I identify my domain restrictions. When you look at this, we see a factor that gets canceled from the denominator. So what value can x not be here? And what about here? 0. Now, here's the one extra thing you need to pay attention to. In this particular problem, it doesn't really apply, but it will in many of the others. And that is, you have to, when you're dividing, so anytime you invert and multiply, you have to consider the domain restrictions. From the original form. Okay, so what that means is we have 0 and 2 here. You have to go back up and look at the entire fraction that you're dividing into the other. Okay? Neither the numerator nor the denominator can be 0 in this case. So every single factor of the numerator and every single factor of the denominator has to have a domain restriction, either implied or written. So here, x can't be 0. I've written it. Here, x can't be 2. I've written that as well. So again, it doesn't necessarily apply here because these both wound up getting canceled out. But you have to account for any domain restrictions from the original form.